This natural log is going to be key for a big shortcut you don't want to miss by the end of this video. But before I show you that, we have to first figure out the limit of the inner cosine function. Now, I'm sure you've already tried this, but if you plug in 0 for x, you're going to have a problem because you'll end up with cosine of 0 divided by 0. And that's an indeterminate form because we can't divide by 0 there. And instead of using something like L'Hopital's rule in this video, what I'm going to use instead is the conjugate method. Now, you can check out the video above if you need a review on this, but long story short, when you have something of the form a minus b on this numerator, I multiply everything by a plus b over a plus b. And if we had a plus b originally, it would be a minus b over a minus b. So the idea with this is that we're trying to get rid of that square root, because now on the numerator, you're going to have a difference of two squares, and that's going to simplify very nicely to an expression on the top where the numerator now is x plus 4 minus 4. And that simplifies to x, right? But because we also have an x on the denominator, we can cancel them out. And don't worry about canceling out x and having a possible x value here of 0, because this is a limit. So we don't have to actually worry about being at 0. Now we're going to have this new expression, and check this out. We can safely now plug in x equals 0 because we no longer have to worry about dividing by 0 here. And when you simplify this further, you're going to get the cosine of this expression, which simplifies to the cosine of 1 over 4. Now what we want to do is take this value and go back to the original problem, which I rewrote for you here, and we want to see what kind of a shortcut we can use here with the natural log. So instead of wasting valuable exam time and spending time trying to find a limit here for the natural log, check this out. We know cosine is continuous everywhere, but the limit that we found for the inner part here resulted in a value that converged, right? We didn't have a problem with the limit not existing. So we got something that was the cosine of 1 over 4. And if you throw this in a calculator, you're going to find that that's greater than 0. Now, the reason why that's important is because that's greater than 0, and because the natural log here has a domain that is continuous as long as x is greater than 0. We can use a property of limits and continuity here, where this outer limit now can be brought on the inside. But we already know what the inside is, right? We found it earlier. It was the cosine of 1 over 4. So you save time here because now you can just simply plug in that